You don't have to just sit and watch. So we're going to go over something called the law of sines. It's pretty easy. That's why I saved it for the end of the year here. So we'll go through it quickly, and hopefully everybody will be in good shape in terms of understanding and end with a good topic. Okay. So I think that when I printed these, the corner got folded, so it should say law of sines up here. So law of sines. So I'll just go through this with you, and hopefully it's something easy to understand. Okay. I think it says in geometry here. It's not a big deal. Okay. So the purpose of this, we've gone through a whole bunch of stuff with right triangles, right? Your right triangle trig, your Pythagorean theorem. You know that the equation of the circle is based off of this stuff. Your special right triangles, your 30, 60, 90s, your 45, 45, 90s. All that stuff has been the basis of what we've learned so far with trigonometry. Okay. The issue with that is we know that not every triangle in the world is a right triangle. We know there's a lot of other different options. Okay, so we want to be able to still do some work with those. Okay, so any triangle that's not called a right triangle, we'll call an oblique triangle. And we have a couple different properties. If we have some given information, we can use this law of sines and something else called the law of cosines to go through and find missing information, whether it's a missing side or a missing angle. Okay, so again, a pretty easy topic. And once we know the setup, all we need is a calculator. And I'll give you a ruler here too, just to help you draw the triangle without too much trouble. And it's not too bad to get through. Okay, so there is a proof that I could do to prove this law of sines, but we'll save that for another time. Just want to get through the problem since we're running out of days here at the end of the school year. So again, any triangle that's not a right triangle we'll call an oblique triangle. And just as a reminder too, when you're setting up triangles on paper, we're going to use ABCD just to keep it easy, or ABC, not the, there's only three sides, three angles. But we use a capital letter for the angle and the lowercase letter for the side, and that's opposite of each other. So same letter for the angle and the side opposite of it. So ABC. Okay, so make sure you understand that. We had that on a previous quiz, and some people still didn't remember to do it that way. Okay. And then the other thing, we can only use this law of sines that we'll talk about in a second in certain situations. The given information that we have to have either has to be angle, angle, side, or angle, side, angle for the first type that we'll do. And then the second type, which is a little bit trickier, but not too bad, is side, side angle. It's a bad word spelled backwards. Okay. So those are the only ways that we can do this. If we don't have a certain amount of information, then this doesn't work. Okay. So again, we could go through and draw in some altitudes and mess around with some things and prove how this works. But when all is said and done, if we have a triangle and certain information, you can say that the sine of angle A divided by the side opposite, which is side A, is equal to the sine of angle B over B, which is equal to the sine of angle C over C. Okay, and whenever you're going through a problem, you're not going to use all three of those. You'll just use two of them. Okay, so you might just use A and B, or you might use A and C, or whatever works well with the information provided. Okay, so what we'll do to get through these problems is we will set up our triangle, plug in what we know, and then use properties of triangles and the law of sines in order to find the other missing information. Okay, so earlier in the year we just used regular SOHCAHTOA, but now we're going to use this law of sines as an additional tool to help us. Okay, so if you didn't already, go grab a ruler. It just makes this drawing these triangles a little bit easier. And then have your calculator available too, because we'll need that in order to do the number crunching. Okay. All right, so this first example is an example of angle, angle, side. That's probably the easiest one. And hopefully, going through this example, there's no pressure in terms of understanding what's going on. Okay, so we've got angle C is 102.3 degrees, angle B is 28.7 degrees, and side B is 27.4 feet. Okay, so what we're going to do first, it says find remaining all remaining sides in angle. Draw this triangle. Okay, since it's got an angle that is 102 degrees, that tells me that I've got an obtuse angle at the top. Obtuse angles are bigger than 90 degrees. So I'm just doing a rough estimate of what that would look like, something like this. Okay, that's probably a little bit too big, but you get the idea. And then do your best to just draw a rough sketch. So I'm not going to grade you on having the most accurate looking triangle. We're just using the triangle for kind of a point of reference to get an idea what the information would look like. Okay, so this obtuse angle up at the top, I'm going to use that to be C, since that's the big angle. No other angle can be that big. So we'll use that. And then the side opposite will be side C. Okay, so we said that angle C is 102.3. And we don't have side C yet, so that's an unknown. Okay, and since this is a rough sketch, it doesn't matter where you put A and where you put B. Both of these angles look relatively similar, so it's not a big deal. So I'll say A is over here, angle A is over here, and side A is opposite of that. And I'll make angle B over here, and side B opposite of that. We know that angle B is 28.7, and side B is 24 or 27.4. Okay, so hopefully none of that is very hard. And then we just want to take a few minutes and find all the other missing information. Okay. Now the reason why this is the easiest type is whenever we have two of the angles, the third one is very easy to find, whether it's a right triangle or something else. All you have to do is understand that the sum of the three angles in any triangle is equal to 180. Okay, so let's find angle A real quick. So angle A is equal to 180 minus the sum of the other two angles. Okay, so I'm pretty confident you could type that into your calculator, add the values up, and then subtract from 180, and that will give you an angle of 49 degrees. So I'm not worried about that. Okay, and we'll just start plugging in information as we find it. Okay, so we've got all three angles. And now we'll finally start to use this law of sines. Okay, so since this is the first time going through this, there's one key piece of information that you want to figure out in order to get through and use this. We need to have a situation where you have, for one of the letters, A, B, or C, both the side and the angle. Okay, we need the values of both, otherwise this doesn't work. So in this particular case, that is letter B. Okay, so what we call that to help ourselves out is called opposite information. So these two values, the B and the B, I call opposite information. Opposite info for short. Okay, so you need to have the angle and the side for a given letter. Otherwise, this law of sines does not work. Okay. If you have that, then you can find all the other missing parts without too much stress. Okay, so we have that with letter B. And then the amount of work for side A and side C is about the same. So I just usually do an alphabetical order when I make a choice like that. So let's find side A next. So we know angle A, that's 49 degrees, but we don't know side A. So we can say the sine of 49 over letter A is equal to, and here's where you get your opposite information. We know what B is for both, so we're going to say the sine of 28.7 over 27.4. Okay. So that's new, but that hopefully doesn't look like rocket science to you. You have three things and you're just missing the fourth. You can use skills that you had probably since 8th grade in order to get through that now that we know this problem. Okay, and again, that's why I saved this for the end of the year, because I think it's an easy thing to, low stress thing to end the year with. Okay, so we're finding side A. Hopefully you remember from earlier math career days that we're just going to use cross multiplication in order to find our missing variable. So you can say A equals, or no, I'm sorry, A times the sine of 28.7 is equal to 27.4 times the sine of 49. Okay, so cross multiply. Okay, and then to get the A by itself, I'm going to divide both sides by sine of 28.7. So we can say A equals this right-hand side here, 27.4 sine of 49 divided by sine of 28.7. Okay, and all we have to do is type that into the calculator, and the calculator will tell us the answer. All right, now be careful. Some students, they don't get to this point and they start typing things in earlier. So you've got the sine of one angle, the sine of another angle, and then another thing to do, a division. Okay, if you do this in the calculator in multiple steps, it's going to round multiple times. Is it a good idea to round and then round again and then round again? No. Okay, your answer just keeps losing accuracy every time you do that. So what I want you to do here is to just get it into this format and then type it into the calculator all at once. Okay, it saves us. We do more of the word scrap paper, and then you'll notice if we keep doing this over and over again, you have the same setup in the calculator. You can use some tricks to save yourself some time. Okay. Now you do want to make sure you check that your calculator is in degree mode. We've been using the calculator for all kinds of different things lately. So just take a quick second and do that. With these big fancy TI calculators, there's a mode button up at the top. You can hit that and just make sure your settings on degrees. It's the third one down. If not, just arrow over to it, down to it, and hit enter, and it'll get you set up. And you hit second quit to get out of it. If you have the little scientific calculator, again, your DRG button is at the top left. You can hit that and make sure it's under D or degrees. And if you're using your cell phone, remember you just have to turn it sideways and just make sure that it doesn't have that rad symbol on the top left. If it does, then the way to change it is the bottom left button. But I think by default it's on degrees, so you should probably be fine. Okay. So however you're using this, what you want to do is type in the whole thing all at once. As you can tell, I did this yesterday, so this answer up here, the 27.4 sine of 49, blah, 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 that ends up giving you an answer of 43.06. Okay. Do make sure, you can still see it on the top of the screen here, there's 49. Make sure you put that parentheses at the end of the 49. If you don't, then your calculator will follow order of operations in a goofy way and not give you the right answer. Okay. And in terms of rounding, I didn't give directions for rounding. Be consistent with the problem that you're dealing with. So in the problem that was given, they round to one decimal place. So you should do that as well. So I would round this to 43.1. Okay, so hopefully that wasn't too bad. You're going to do the same thing for side C. And just like with right triangle trig at the beginning of the year and solving the triangle back then, I recommend really just making sure that you always use the given information as much as possible. So we're going to do this virtually the same way. And we're going to use side B and angle B as part of our ratio. because I know that that was correct because it was given to me, and then just go through the same exact process and find side C. Okay. So you want to use your space wisely here. Maybe I should have started down here on the bottom left and gone over to the right, but I'll do side C over here. So side C, we're going to say that the sine of 102.3 over little c, lowercase c, is equal to the sine of 28.7 over 27.4. Okay, so you can see the math is going to be exactly the same. The only difference is instead of the 49-degree angle, you have this 102.3 angle. Instead of the letter A, it's the letter C. Everything else is exactly the same. You cross multiply and then solve for C. Okay, so hopefully that's pretty easy. You'll see in the calculator, it almost looks identical, except for where it said sine of 49 in the previous one, it's just sine of 102.3. Everything else is the same. If you know some of the buttons on your calculator, you can copy and paste your previous work and reuse that, and just change the 49 degrees to 102.3 degrees. Okay. If you're not familiar with that, it's still not too bad to retype the whole thing. Okay, but you cross multiply just like you did on the previous one. Just divide to get C by itself, and then we could just type this whole thing into our calculator, and it shoots out the answer. Okay, unfortunately, since it is not a right triangle, we cannot use the Pythagorean theorem for the third side. That's a question that comes up sometimes. The answer is no. Right triangle, Pythagorean theorem only works for the right triangle. Okay. All right, so again, you would just take a second and type that into your calculator. Again, if you know some of the buttons, you can save yourself some typing by rewriting, copying and pasting the previous formula and just changing the 49-degree angle to the 102.3. If you'd like me to show you some of those tricks, I'll be happy to. If you don't want to worry about memorizing those, then you could just retype. It's not that big. So, no big deal. When you do that, plug it in. It's this information right here. Again, just be careful that the biggest mistakes people make is after that first sine function, they forget to close off their parentheses before hitting the divide symbol. If you don't close off that parentheses, it will give you the wrong answer. So when you do everything correctly, you get a 55.7 length in terms of your side C. Okay. So you just write that in on your triangle here and just double check and make sure you have all the missing parts. So I've got all sides and all angles. I am done. Okay. So hopefully that's pretty easy. That was the goal. What we'll do now is give you a few minutes to try example 2 on your own. It is very, very similar. The only thing that's a little bit different is you are not given opposite information right away. You don't, like in this first example, angle, side, you have side A and angle B right away. Or I'm sorry, side B and angle B right away, and you don't have to worry about obtaining opposite information. With the next example, you have to do one step in solving the third angle before you have opposite information. But once you have that, then you're fine. Okay, so I'll give you 3 or 4 minutes. Try to do this one on your own. Hopefully it's not too bad. Again, those of you that are watching the recording of this, you'll probably be able to fast forward until you see me working on the screen again. Okay, but we'll take 3 or 4 minutes, try this one on our own, and see how people do. Yeah.
In the grade book, there's a law of signs. Is there's the one on my desk, the law of signs?
The one that says practice law.
Yeah, that's the one that's in the grade.
Yeah, that one will be agreed. Okay, so you should be trying this on your own, right? Got it.
I really thought it was easy.
No. Well, side A has to be opposite angle A, and side B has to be opposite angle C. All right, we'll give it another 30 seconds or so, and then I'll start going over it. Okay, so kind of in reference to people that tried this and you're done waiting, let me get this up here. Again, the goal is not to have a perfect drawing over here. That's not what I'm looking for. It would be nice, but you know, these angles, even in retrospect, me looking back at this, these angles should have been a little bit more steep. A 90-degree angle is just a little bit bigger than both of these, so I probably should have made it more steep. And then a 15-degree angle, which is perfectly fine, probably should be a little bit skinnier. But that kind of level of detail is not that big of a deal. What I want you to do is to be able to set up the given information correctly. I've got my angle C, side C, angle B, side B, angle A, side A, opposite of each other, and then label what I can, and then plug in actual values that I know. Now, right away from the given, I don't have opposite information, but I find it very quickly after the first step where I find angle, actually it's not angle A, I wrote down angle A, it should be angle C, right? The first thing you do is angle C. So probably should have drank a little more coffee that morning. That's angle C, we find it to be 15 degrees right away. And then once you have that, then you have your opposite information, as I've talked about a lot. Then from there, we can find either side A or side B next. Doesn't matter which one you do first, as long as you have them all. I usually just do them in alphabetical order. And then it doesn't matter which ratio you put first or which one you put second. It's all the same since those are equal to each other. Okay. So I put the opposite information one here first, which was side B and angle C. Okay. And in the word, you don't have to put the parentheses if you don't want to, but I usually do it at the end just to remind myself of how I want to type it into the calculator. I call that calculator ready form. So you do the same thing as what we did in the previous one. You cross multiply and then divide by whatever's connected to the A through multiplication, and then just type it into your calculator. Okay, so you can just check your work there, and hopefully it's not too bad. The original information was rounded to the whole numbers, but I left one decimal place because it seemed like that was perfectly fine. If you round it to the nearest whole number here, that's not a big deal either. Okay, so kind of based off how you round, based on the given information. If you want to go more detailed in terms of decimals, that's never a good, you know, I would never take off for that. Okay. All right, so I'll leave this up for another 20 seconds or so, and then we'll go over the one on the back, just to get people what they need in order to get through the practice worksheet that you have. Okay. All right, while you're finishing looking at that, the one on the back is just a little bit harder. It's not terribly difficult, but it's something we haven't done in a while. You have in the given information it's side angle, so it's only one angle is given to you in the beginning, so we can't do it in exactly the same way. Okay, so if you haven't finished copying these, just pause it, take a picture, and then do it your own side, but at your own time. But we want to go over the one on the back. We'll hold off on the word problem for now, but we can take a look at example 3. Okay, so this is again the side angle. There is a different level of expectation here because we only have one angle, but we can still get through this. It just takes an extra step on our calculator. Okay. So you don't have opposite information and you can't find it very quickly in terms of an extra angle. But you do have opposite information, but the tricky thing here is that you don't have that extra angle to work with. But so I said that wrong. You do have opposite information. That's these, side C and angle C. But what we don't have is that extra angle. Okay. So again, it doesn't matter which one you want to find next. You can do angle A or angle B. Doesn't matter. Actually, I guess, man, I'm struggling. You do have to use A, I guess, next because we don't have anything about B. Okay. But whichever side you have to have the opposite there. Okay. So we can say sine of 102 is equal to 20 over 24 is equal to the sine of A over 18. Cross multiply like we typically do, but the difference here is instead of just an A by itself, we have the sine of A. Okay, so once we divide by 24, you've got the sine of A left over on the other side. Okay, so if you remember from earlier in the year, to isolate the A by itself, we use what's called the inverse trig function, so sine -1. Okay, so the way that you would find A in your calculator would be this sine -1, and then everything else left over on the other side inside the parentheses. Okay, just make sure again, just like we had to worry about before, after this sine of 102, that you have a little closed parentheses there so that we don't do 102 divided by 4. We want to do the sine of 102, 18 sine of 102 divided by 24, not just the angle. Okay, so you need that parenthesis in your calculator in order to get this. All right, as long as you're in degree mode, you should get a 47.2 degree angle. Okay, so you can plug that in. And then from there, the third angle is pretty easy. Now you can just subtract from 180 in order to find that. But then you can go back to your last step. You can see, you might have to write it a little small down here. It's not a lot of space. Use law of sines the normal way in order to find that third side. Okay, so just a little different, but not terribly bad. You just have to use the inverse sine function, which we haven't used in a couple months. Okay. So that should be enough to get you through the practice page that was up front. That is one of the few remaining assignments for the year that you're going to submit and hand in. So make sure you get that done. I won't collect it on Monday, but you do want to get it in by like Wednesday next week. That way you can have it in the grade book. Okay. So that's it for today. Again, hopefully this is an easy topic to get through. It just will require a little bit of practice next week. Okay, let me know if you need anything. Otherwise, have a very good afternoon and a nice weekend.